In this video, we're going to solve two questions on trigonometry. So mixed exercise 7.01 is on trigonometry, A-level pure maths, year 2. Question 1. By writing 3 theta as 2 theta plus theta, show that cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. B. Hence, prove that cos 3 theta over cos theta minus cos 6 theta over cos 2 theta is equal to 2 brackets cos 2 theta minus cos 4 theta. So for A, cos 3 theta can be written as cos 2 theta plus theta. If we use the compound angle formula, which is cos A plus B equals to cos A cos B minus sine A sine B. If we apply this rule to this, we're going to get the following. Cos 2 theta cos theta minus sine 2 theta sine theta. But you also know that cos 2 theta is equal to 2 cos squared theta minus 1. Also, sine 2 theta is equal to 2 sine theta cos theta. So we're going to replace cos 2 theta with this and then sine 2 theta with this one. We're going to get 2 cos squared theta minus 1. All that multiplied by cos theta, which is here. Then minus, I'll replace sine theta with 2 sine theta cos theta. So I'll get 2 sine theta cos theta. And I'll multiply it by sine theta, which is this one here. I'm going to expand this one and simplify this term as follows. Cos theta times 2 cos squared theta will be 2 cos cube theta minus cos theta. Then if I simplify this, I'm going to get minus 2 sine squared theta cos theta. But we know that sine squared theta is 1 minus cos squared theta. So I'm going to replace this with 1 minus cos squared theta. Then if I do that, I'm going to get 2 cos cube theta minus cos theta minus 2 brackets 1 minus cos squared theta, close the brackets and multiply by cos theta. We now expand this one here to get the following. So this will remain the same, 2 cos cube theta minus cos theta. Then if I expand this one here, I'm going to get 2 cos theta, so minus 2 cos theta. And then this times that will be plus 2 cos cube theta. I've got like terms here. So this and this are like terms. If I add them, I'm going to get 4 cos cube theta. And I can also see that this and this are like terms. If I add them, I'm going to get minus 3 cos theta. And so let's do that. I'm going to get 4 cos cube theta minus 3 cos theta. And that is the proof required as shown over here. So for B, cos 3 theta over cos theta minus cos 6 theta over cos 2 theta. We have just proved that cos 3 theta is equal to 4 cos cube theta minus 3 cos theta. So we can replace cos 3 theta with this. And so we are going to get 4 cos cube theta minus 3 cos theta over cos theta. We can use a similar identity to this one to rewrite cos 6 theta. If we replace 3 theta with 6 theta, then we can replace theta with 2 theta and 2 theta over here. So the identity that we are going to use will be cos 6 theta is equal to 4 cos cubed 2 theta minus 3 cos 2 theta. So we're going to replace this with this one. So I'm going to get minus 4 cos cube 2 theta minus 3 cos 2 theta. And I need to put all that in brackets. I'm going to get cos 2 theta here. So this is equivalent to this. So this one can be reduced because we can divide cos theta into the numerator to get the following. So we're going to get 4 cos squared theta minus 3 minus brackets. Similarly, cos 2 theta can be divided into the numerator to get the following. 4 cos squared 2 theta minus 3. Close the brackets. So we've got a simple equation. We can now expand these brackets here and simplify 4 cos squared theta minus 3 minus 4 cos squared 2 theta plus 3. And we can start this 3 and that 3 go. And we're going to get 4 cos squared theta minus 4 cos squared 2 theta. We are going to use another identity to simplify this. And that identity is cos 2 theta is equals to 2 cos squared theta minus 1. So from here, if I make 2 cos squared theta the subject, I'm going to get 2 cos squared theta is equal to cos 2 theta plus 1. So I can rewrite it in the convenient form to enable me to substitute this one here easily. So this can be written as 2 times 2 cos squared theta, so that I can just replace 2 cos squared theta with cos 2 theta plus 1. I can write a similar identity for this as follows. 2 cos squared 2 theta will be equals to cos 4 theta plus 1. And so I can use the same reasoning to simplify this to enable a very effective substitution of this. And I can do that by doing 2 times 2 cos squared 2 theta. So you can see I'm going to replace this with that and this with this one here. So if I do that, I'm going to get the 2. Then instead of this one, I'm going to replace it with this. So brackets cos 2 theta plus 1, then minus 2 brackets cos 4 theta plus 1. I can now expand to get 2 cos 2 theta plus 2 minus 2 cos 4 theta minus 2. And as you can see, this and that reduced to 0, and then I'm left with 2 cos 2 theta minus 2 cos 4 theta. If I factorize this, I'm going to get 2 brackets cos 2 theta minus cos 4 theta. And this is the proof required as shown here. Question 2. Given that alpha and beta are acute angles, such that sine alpha is equal to 2 over root 13 and sine beta is equal to 1 over root 5, find without using a calculator the exact value of sine alpha plus beta. So we need the exact value of sine alpha plus beta. So sine alpha plus beta needs to be expanded, and that gives us sine alpha cos beta plus sine beta cos alpha. So we need to find these values here and do our substitution. But the only values we've got are sine alpha and sine beta. So what we do now is draw right angle triangles and use SOHCAHTOA. If I say this is alpha, then from here, sine alpha according to SOHCAHTOA is opposite over adjacent. That means this is 2 and this is root 13. That means that to find this length here, I can use Pythagoras Theorem, and so I'm going to get square root of root 13 squared, which is 13, minus 2 squared. And I'll get square root of 13 minus 4, that will be square root of 9, and that gives 3. So it means this side here is 3. I can do the same thing for beta. So if I do 1 for beta, this angle is beta. And again, sine beta is equal to 1 over root 5. That means this is 1 and this is root 5. Using Pythagoras Theorem, we have square root of 5 squared, which is 5, minus 1 squared. That gives me square root of 4, and that is 2. So it means this length here is 2. So now I can write down my values for the cosine of alpha and the cosine of beta. From here, cos alpha will be equal to 3 over root 13. And from here, cos beta is equal to 2 over root 5. So now I can do my substitution in this equation here to get sine alpha plus beta equals to sine alpha, which is 2 over root 13 times cos beta, which is 2 over root 5 plus sine beta, which is 1 over root 5 times cos alpha, which will be 3 over root 13. So now we can simplify that to get 4 over root 65 plus 3 over root 65. Simplifying that gives us 7 over root 65. And that is the exact value required. If we want, we can rationalize this to get 7 root 65 over 65. And so with that, we come to the end of this session. Thank you again for watching. I'll see you in the next video.